Hello, everyone. I'm back. And this video today is for the Camden County College statistics students, Math 111 students. And this is on the fourth video on confidence intervals. This is the last video for chapter 6. And on Tuesday, I covered section 6.3, which is on confidence intervals to estimate a population proportion. And today I'm going to actually show you the steps to go through to solve confidence interval problems that you may show up on your test number 3. What we're going to do today is again go right to the textbook, and I selected some problems to go over. This should not be a really long video today. It should be relatively short compared to the ones we've been doing recently, but it should help you understand how to do confidence intervals for estimating population proportions. Last Thursday, my video was examples of doing confidence intervals to estimate a population mean. So for our next test, we'll be doing estimating both means and proportions using confidence intervals. So it would be good to make sure that you've reviewed all these 4 videos carefully, maybe more than once, so that you'll be able to do not only the homework, but do test number 3. Okay, so let's go ahead and share the screen. Okay, and we'll go directly to the textbook. There we go. And let's actually go to the previous page. We're going to go to page 325 if you're following along. 325 in the textbook. All right, and just get my notes here. And we're going to go to problem number 7. So we're going to scroll down to number 7. All right, now 7 through 10, those problems that you see there, they are already formed confidence intervals. In other words, somebody's already created these confidence intervals. And what they're asking you to find using the display of these confidence intervals, number 1, they want you to find the margin of error that was used to create the confidence interval. And the second thing they want you to find is the point estimate, the sample proportion that was used to construct it. So how do you do that? Well, let's get to the actual solutions for 7 through 10. Good. All right. Now, one of the things that you have to think about when you construct a confidence interval is that what you're doing for the left end of the confidence interval is you're taking the point estimate, the sample proportion, and you're subtracting the margin of error, right? So it's p hat minus e, okay? On the right end, you are adding the margin of error to p hat plus e. Let me just see if I have the formulas here. Yeah, here it is right here. So this is number 1. So the left end of the interval is the p hat minus the margin of error. Margin of error is the critical value z times the square root, which is the standard error for a sampling distribution. On the right, we're adding to p hat the margin of error, the same formula that you see on the left, except adding the z times the square root on the right, and we're subtracting it on the left, right? So that's how we end up forming a confidence interval. So let's go back to the problem that we were looking at, the problems that we were looking at. Now, one of the things that hopefully would make some sense to you is that if this left number here is the result of subtracting the margin of error, and if the right number here is the result of adding the margin of error to p hat, then it should make sense to you, I hope, that the difference between these two numbers must be 2 times the margin of error, because we're moving to the left by the margin of error, or the left interval here, and we're moving to the right by the margin of error when we create the number on the right here, right? So we're going from p hat, we're subtracting e, we're starting from p hat and we're adding e. So the difference between these two numbers should be 2 times e. How do we find the margin of error? Well, if the difference is 2 times e, that means 1/2 of this difference must be e, the margin of error. So that's how we do it. Go back to our solutions. So the margin of error is simply the right endpoint minus the left endpoint divided by 2. When we subtract these two numbers in the numerator, we get 0.28. And when we divide that by 2, we get 0.14. So whoever created this confidence interval used a margin of error of 0.4. Now the question is, what was p hat? Well, there's 2 ways. Once you find your margin of error, there's actually 2 ways of finding the sample proportion. 2 ways. One way is, even if you don't know the margin of error, is simply finding the average of the 2 endpoints. When we find the average of 2 numbers, we're finding the number in the middle. And isn't it true that inside this interval here, the number in the middle must be the point estimate, this sample proportion? So we simply add, for the point estimate p hat, we simply add the 2 endpoints and divide by 2, and we get 0.919 as our sample proportion, the number in the middle. If you've already calculated the margin of error, an alternative way of finding the p hat is simply take your left endpoint and add the margin of error. Since this left endpoint is the result of subtracting the margin of error, you do the reverse to find p hat. So you take find p hat, you take your left endpoint and add the margin of error, and notice that it comes out to the same number, 0.919. So whichever method you want to use, if the multiple choice question on a test is asking for, gives you the interval and asks for the sample proportion, it might be easier just simply to average the 2 and come up with your answer. But if you've already answered a question about the margin of error from this, then you can simply just add that to the left endpoint and get the sample proportion. Either way, you're going to get the same answer. And we do the same thing for the other ones that are here. Here's our confidence interval, margin of error. You subtract the 2 endpoints and divide by 2. 0.42 is the margin of error. The sample proportion, the point estimate, we find the average of the 2 endpoints, 0.554. And again, here's the alternative way of finding it. All right. So 8 and 9 is what I went over with you. I think there were others that are in the textbook. Yes. I'm sorry, I think I did 7 and 9. I did the odd number ones. You do have the answers in your book, so that's why I gave you those as examples. If you wanted to, you could try 8 and 10 on your own and use the same formulas to find both the margin of error and the sample proportion. All right, our next problem is problem number 11. Here's where we're actually going to construct confidence intervals. All right, we're going to start with the data, and we're going to construct the confidence interval. Now, what we're going to do is we're going to do number 11 and then number 12 here. Number 11. Now, notice that in the problems here, it says in exercises in 11 and 12, construct 90 and 95% confidence intervals. for the population proportion. So they're asking you to do both confidence intervals for each one of these, 11 and 12. But what I'm going to do, just to save some time, and maybe if you want to try the other one, is I'm doing the 90% confidence interval for number 11, and I'm doing the 95% confidence interval for number 12. All right, this is illustrations of how to do it. All right, in number 11, it says in a survey of 2,241 U.S. adults in a recent year, 1,322 said they have made a New Year's resolution. So we're going to construct a 90% confidence interval that estimates the population proportion. So this is a survey, not obviously there are millions of US adults, and we want to construct the confidence interval. Now, one of the things now that we have to establish, when we do a confidence interval, we have to establish that we can use the normal distribution to come up with our margin of error. It's specifically to come up with our z critical value. We can't use the z, which is the standard normal, if the sampling distribution is not normal. So how do we determine that again? What we do is we take n, the sample size, which is 2241, and multiply by the sample proportion. Now, what is the sample proportion? It's 1322 divided by 2241. So when you multiply 1322 divided by 2241 times 2241, obviously you're going to get 1322. The 1322 is the result of multiplying n times p hat. N times 1 minus p hat is simply going to be, 1 minus 1322 divided by 2241. By the way, that is equal to, if I do the math correctly, that's equal to 919 divided by 2241. That's q hat, or 1 minus p hat. And if you multiply that by 2241, you're going to get 819. I'm sorry, not 919. Mental math incorrectly there, 919. And that's, again, so n times p hat and n times 1 minus p hat are much, much larger than 5. If you remember, that was the criteria for determining if we can use the normal distribution for our sampling distribution of p hat. And the answer is yes. So both of those, n p hat and n times 1 minus p hat, are both much larger than 5. All right, so we've established that. All right, so let's now go to how to come up with the confidence interval. All right, so this is going to be number 11. I've written down n is 2241, x is the count of the number of people. Now, what was the problem again? The number of people who made a New Year's resolution. All right, so they polled 2,241 US adults in a recent year, and 1,322 of them said they made a New Year's resolution. That means the other 919 did not make a New Year's resolution. All right, anyway. So p hat is, if we divide these two numbers, we come up with, if we round it to 4 decimal places, 0.5899 is our sample proportion. Okay. A 90% confidence interval means what? Means that our z critical value is going to be 1.645. Now, once again, how do we get that? So let's go back to this handout, z critical values. Remember, if c is 0.90 or 90%, that means the middle area of the standard normal curve is 90%, which means half of the remaining 10% is on the left, that's 5% on the left tail, and then the other 5% is on the right tail. So define z double prime, which is our critical value. We're going to use inverse normal in our calculator. And the area to the left of the critical value is going to be this 90% plus the 5%, which is 95%. I wrote it as 1 minus 0.05 because the area to the right is 0.05, the area to the left is 1 minus 0.05. But I hope hope you understand that in both calculations it would either be 1 minus 0.05 or 0.95. It's the same. It's a z, so we use our mean as 0 and our standard deviation as 1. And we find the answer, it rounded to 3 decimal places, as 1.645. So that's how we came up with our z critical value. All right, so let's go back to our solution here. What's inside the square root? Well, it's the estimate in the numerator of p hat, 0.5899. Then next to it is 1 minus p hat, which is 0.4001. And it's divided by the sample size, n, which is 2,241 people, which is the number of people surveyed. When we multiply this with our calculator, we come out to, rounding the 4 decimal places, 0.0169. And then what we do is we take this 0.0169 and we subtract it from p hat for our left endpoint, add it to p hat for our right endpoint. And so we end up with, on the left endpoint, 0.5730, and the right endpoint, 0.6068. Now, typically in exams, we see this way of showing the confidence interval. We're saying that the true population, the true unknown population proportion is hopefully in between these two values. With how much confidence? 90% confidence. That is, if we repeated this process for all samples of size 2241, we would find that 90% of those samples would have confidence intervals that would contain the actual population proportion, and 10% would not. So we're 90% confident that this interval here from the sample that we chose actually contains population proportion. Another way of writing it is with parentheses. We write the left endpoint inside the parentheses on the left, a comma, and then the right endpoint to the right in the closed parentheses. Both of these are 2 ways of writing the confidence interval. And this is a 90% confidence interval. So how would you interpret this? You would say with 90% confidence, I would expect that the proportion, and again, let's go back to the problem, the proportion of all US adults who make New Year's resolution is between, let's go back, is between 0.573 and 0.6068. In other words, between 57 and 3% of the population, US adults, and between 57.3% and between, and the other end would be 60.7%. Let's say we round up the percentage. Okay, that's all right. Anyway, that's the confidence interval for number 11. Number 12, I think it's the same survey, but we're going to be asking a different question for this survey. Here. In this question, in that survey, 650 made a New Year's resolution to eat healthier. So out of the 2,241 adults, we're now being a little more specific. We're saying that 650 of them made a New Year's resolution to eat healthier. All right, that means 672 did not, made other New Year's resolutions. The difference between these two numbers here. Okay, regardless, we have a different sample proportion here. But now we're dealing specifically with a New Year's resolution to eat healthier. 650 said yes, and the remaining either made a New Year's resolution that did not have anything to do with eating healthier, or they just did not make a New Year's resolution. Okay. All right, anyway, let's go back to the solution. So for number 12, same sample, right? Same sample of people. This time the number of successes. The number of people who answered yes to eating healthier as a New Year's resolution is 650. And this time we're going to use a 95% confidence interval. That's what I chose to do in this case. If you want to try doing this with a 90% confidence interval on your own, you can certainly do that. When we divide these two numbers, we end up with 0.29 as our sample proportion. Now, what's the margin of error? Well, z.95 is our critical value. And if you had remembered from our doing other 95% intervals with z's, the z is 1.96. Maybe you're familiar with that by now. But if you wanted to find it, you would use inverse normal. And again, you would make the middle of the standard normal curve 95%. Let's go ahead and find that again. Let's scroll down to the next one. Here it is. So the middle area now is 95%, which means there's 5% remaining, half of it to the left, half of it to the right. So the left tail's 2.5%, the right tail's 2.5%. So the area to the left of z, the critical value, the positive critical value here, is the 95 plus the 2.5%, which is 0.975. Or you could say it's 1 minus the area to the right, which is 1 minus 0.025. In either case, this is 0.975 if you want to write it that way, or you could just write 1 minus 0.025. And again, standard normal mean is 0, standard deviation of 1. And here, and again, with your calculator, you end up with 1.95, and there's a bunch of 9s after that. It's really 1.96 is what most people use as the critical value for a 95% confidence interval. And we use a z critical value. Okay, so that's where in this problem, that's where they use 1.96 here as our critical value. We're going to use 0.29 as our inside the square root, inside the standard error. Here we're going to use 0.29 as for p hat. 1 minus p hat is 0.71, and the sample size is 2241. We multiply these two, we end up with 0.0188 is our margin of error. And then we add and subtract it from our p hat, 0.29. So on the left of the interval, it's p hat minus e. On the right, it's p hat plus e. On the left, it's 0.29 minus 0.0188. On the right, it's 0.29 plus 0.0188. And we end up with this confidence interval. And we can write it this way also. And again, we would say in this case, with 95% confidence, we could say that the population proportion of people who made New Year's resolution to eat healthier is somewhere between 27.1% and 30.9%. These percentages in our interpretation of what? Of all U.S. adults, right? Yeah. All right, let's now go to number 13. Okay. Number 13. Now, number 13, we're going to be using a 99% confidence interval. So as you can see, I'm giving you practice using different levels of confidence in constructing these intervals. 90%, 95%, and 99% are the most commonly used levels of confidence, but in a problem, any other level can be used. You can use any percentage if you want. You can use 80%, you can use 98%, I've seen 92%, 85%, whatever. It's constructed in the same way by drawing a normal curve and making the confidence level be the middle percentage. Then you find the two tails, and then you can find the area to the left using inverse normal. Then you get your critical value. It's the same procedure. So anyway, in number 13, the problem is, it says police body cameras. In a survey of 1,000 U.S. adults, 700 think police officers should be required to wear body cameras while on duty. Yes, to show exactly how they handle tense situations. That way, we know when police officers might be lying about what they did. Anyway, all right, so N, the sample size is 1,000. The number of police officers, the number of the 1,000 adults who believe a police officer should be wearing these body cameras, 700 of them said yes. That means 300 of them said no. So the proportion, the sample proportion in this particular case, in number 13, is going to be 700 divided by 1,000, or 0.70. We're going to use a 99% level of confidence, so 0.99 is C. And once again, we're going to use this formula for a margin of error, but this time we're going to use a Z critical value for a 99% confidence interval. Notice that what I put in here is 2.5758. Question is, where do we come up with that? Well, this time I'm not actually going to use the calculator to show you this. So I'm going to do second, the ARS, scroll down to inverse norm, hit enter. Now, what do you think I'm going to use for the area to the left if it's a 99% confidence interval? Let's go again to those drawings here. Let's scroll down to the 99% one. Well, if the middle area is 99%, that means we have 1% remaining, half of it to the left, that's half of a percent, and a half of a percent on the right. Now, by the way, to convert a percentage into a decimal, we divide by 100. So when we divide 0.5 by 100, we move the decimal point over to the left by 2, and we get 0.005 as the area to the right. So 1 minus 0.005 is the area to the left, which happens to be 0.995. 0.99 plus 0.005 is 0.995. And here I rounded it to 2 decimal places, but if you use your calculator, and I'm going to put, in this case here, 1 minus 0.005, 1 minus 0.005, scroll down and hit enter. And again, if you have an 83 calculator, obviously you have to put it in this order. And there we go, 2.57. And if we round the 3rd decimal place, it would be 2.576, or I think I used in this case 2.5758, rounding at the 4 decimal places. That's what I did. Yes. That's where I got the critical value for a 99% confidence interval. This is the Z critical value. Inside the square root, we have our point estimate p hat is 0.7. That means 1 minus p hat is 0.3. We divide by 1,000 inside that square root. And then we come up with our margin of error is 0.0373. Once again, our confidence interval, or left endpoint, is going to be p hat minus the margin of error, 0.7 minus 0.0373. And then on the right is p hat, 0.7 plus 0.0373. So when we subtract here, we get 0.6627 on the left, 0.7373 on the right. You can also write a confidence interval this way. And the way to interpret it, we could say with 99% confidence, we could say the proportion of people who think policemen should be wearing body cameras is between the actual proportion of all people who say that policemen should be wearing body cameras is between 66.3% and 73.7% of all people, all adults. Okay. Then let's go down to number 17. Number 7. Okay. We did 11, we did 12, we did 13, and now we're going to do number 17. This is the last problem that we'll be doing today. Let's look at number 17. This is on page 327. Or 326, I'm sorry, 326. All right, number 17. Let's actually move my picture here out of the way. All right, you wish to estimate with 95% confidence the population proportion of US adults who think Congress is doing a good or excellent job. Your estimate must be accurate within 4% of the population proportion. And what A is saying is there's no preliminary estimate for what? For the sample proportion. Okay, you need an estimate. We'll see that in a minute. Find the minimum sample size needed. Now, if you remember, last Thursday, we did a problem like this when we were finding the minimum sample size for a confidence interval that estimated a population mean. Now we're going to be doing the same type of problem when we're going to be doing some research on estimating a population proportion using a confidence interval. So if you remember, before you actually do the study, you have to determine how many people you want to interview. So how do you determine that? Well, you use the margin of error formula to solve for n. So let's go back to our problem here. Here's the margin of error formula for estimating a population proportion. Notice there's a square root here, and we want to solve for n. So it makes sense that we have to square both sides of the equation. So get rid of that square root. And then when we rearrange the equation and solve for n, we get this form of the equation. It's the same equation solving for n. So on the left here, we see our critical value divided by the margin of error, the quantity squared, and then it's multiplied by p hat times 1 minus p hat. Now, in this problem, it said that the researcher determined upfront, before doing the research, they wanted to create a 95% confidence interval. And what else did they say? What else they said is they wanted the estimate to be accurate within 4% of the population proportion. Within. The number that's after within, this here, that's our margin of error. Look for that word within. Now, if it's expressed as a percentage, we have to convert it into a decimal when we use it in the margin of error formula. So we have to convert this to a decimal, and again, divide it by 100. 0.04 is the decimal equivalent of 4%. All right. They're also saying in part A, there's no preliminary estimate for p hat. Okay. Well, the question is, what do you do? Well, if you remember from Tuesday, we did mention this, right? We did mention it. He said, if there's no estimate for p hat and we want to find the minimum sample size, we use 0.5 for p hat, which also means that 1 minus p hat is also 0.5. So if there's no preliminary estimate for p hat, we use 0.5. All right, anyway. So the researcher wants a 95% confidence interval. We know that the z has to be 1.96. We just did a problem like that a few minutes ago. All right, using inverse normal, we know a 95% confidence interval has a z critical value of 1.96. So that's what we're going to fill in here for z. For e, we're going to fill in the 0.04. And then because there's no preliminary estimate of p hat, we use 0.5 for p hat, and 1 minus p hat is also going to be 0.5. So fill this all in. We're going to square this ratio, multiply it by these two numbers here, and we get n is equal to 600.25. And remember, we're trying to determine a sample size or survey. How many people are we going to survey? You can't have a quarter of a person unless it's a baby or something. That might be a quarter of a person. but a baby can't answer any questions. So we're going to round this up to the next whole number, 601 people. That's the minimum number of people that we would need to survey to meet the conditions that our confidence interval is a 95% confidence interval, and that our margin of error is 0.04. Okay. Now, what if, let's go to part B, the second part here, part B here. Find the minimum sample size needed using a prior survey that found that 25% of US adults in Congress is doing a good or excellent job. So that's going to be our estimate for p hat. It's from my previous study, a previous survey. So we're going to use that number as our p hat to find the minimum sample size. So in this particular case, let p hat equal 0.25. And that means 1 minus p hat is 0.75. So the same ratio here in this z divided by e, same thing. But p hat now is 0.25. 1 minus p hat is 0.75. And this is going to be equal to, when we multiply all of this, 450.1875. And we round that up to 451 as our minimum number of people. Now, I want to show you something. I want to actually show you how to put these numbers here into your calculator. Some of you sometimes, I think, are not quite clear how to actually put this into your calculator. And sometimes if you do it incorrectly, you could come up with the wrong number. So it's important to know how to do this in one step. I'm going to go back to the calculator, and I'm going to clear this out here. And what I'm going to do is show you how to find that n in this particular case. So what you're going to do is open up a set of parentheses, and you're going to type in 1.96 divided by 0.04. Now you're going to close the parentheses, and we need to square this. Now the easiest way of squaring this parentheses, once you close the parentheses, is to go over to your x squared button and hit x squared. Notice what happens. It automatically squares the parentheses. What's inside the parentheses is all being squared, which is what you want. And the cursor comes down ready for the next operation, which in this case is going to be times 0.25, right? That's our p hat. And then times, and let's say you didn't know or didn't want to figure out mentally what 1 minus p hat is, you could simply open up another set of parentheses and do 1 minus p hat, in this case 0.25, close parentheses, and now you hit enter, and there's your answer, 450.1875, and you round up to the next whole number, 451, and that's what we got. All right, so I just wanted to show you those steps so that you don't make any typing error into your calculator and you come up with the correct answer. All right, so that is it for today. I showed you some examples, several of the examples of how to construct a confidence interval. This last problem here, I showed you how to come up with a minimum sample size given a confidence level, a margin of error, and also an estimate of the p hat. And also I told you that if there was no estimate given, you would use 0.5 for p hat. So you had to do that. And then at the beginning of this handout, I showed you how to find both the margin of error and the sample proportion, the point estimate, if you were given the confidence interval. In other words, you were not given any information about the confidence level or the margin of error or sample proportion. You were just simply given a confidence interval, and you were being asked to find the margin of error and the sample proportion. So I wanted to show you how to do that also. All right, so that is it for today. And that is it actually for chapter 6. So let me stop sharing here. So we've now completed chapter 6, sections 6.1, 6.2, and 6.3. Section 6.4 is not covered. We will not cover this in this course. It's a little bit beyond the scope of Math 111, so we're not going to cover that. And so next week, we're going to go into Chapter 7. Chapter 7 is called hypothesis tests. It's a type of thing that researchers do. In this particular chapter, Chapter 6, we don't know what the population proportion or population mean is, so we estimate it using a confidence interval. But suppose we're a researcher and we have a sort of an idea, a hypothesis about what that population proportion could be. All right. So we have some information and we want to test to see if our theory is correct. So what do? We draw a sample, we look at the sample statistics, and we use the sampling distribution to come up with a method of deciding whether your theory is correct or not. So we're going to go on into this next week. We're going to take, again, 2 weeks on this. On next Tuesday, what we're going to do is we're going to look at sections, principally section 7.1. 7.1 is basically the introduction to hypothesis tests. So you need sort of a little bit of a background for this. It's going to take probably the entire video on Tuesday of next week. Then what we're going to do is we're going to cover, so that's 7.1. On Thursday of next week, we're going to cover section 7.2 and 7.3, where we're going to be estimating using the a hypothesis test to do research about a population mean. And then the following week we're going to talk about a hypothesis test for proportion. Anyway, I'll be splitting up the videos so that you'll be getting some videos will have problem solving in it, and some videos will not. And so don't worry about that. I will make sure there will be several problems, several examples to show you in problem solving in terms of hypothesis tests. So please, please, please make sure that you are on schedule and that you start viewing the videos on Chapter 7 starting next week. And finally, after we're finished the 2 weeks starting next week, we're going to be doing we'll have our sample exam for test number 3 for the following week. And then I had mentioned that the following Tuesday after that, which I believe is May the 12th, would be the day of the final exam. All right, not the final exam, I'm sorry. Test number 3, test number 3. So test number 3 will be on Tuesday, May 12th. All right, so the week before that will be, you'll be getting a sample test number 3. You'll be doing it at the end of that week. I'll be showing you the solutions, but you should definitely try it on your own. Again, Q&As will be mixed in. And then on Tuesday, May 12th will be the test. Now, the goal here is for you to complete the course on May the 12th. And that's the whole point of making it the last test on May 12th. Please, please organize your schedule so that you can take the test on May the 12th. It will have to be an absolute emergency for you not to be able to take it May 12th. God forbid if you got the virus or your close family member got the virus and you were incapacitated or not able to take the test that day, that would be one reason not to. But don't come back to me later and say, oh, I didn't know, or I missed that email. I'll be giving you plenty of email reminders about this. So it's, again, test number 3 is on May 12th. Now, since we've now completed Chapter 6, a week from tomorrow, a week from Friday. Now, Friday, tomorrow's date, I believe, is the 17th. So April 24th, Friday, April 24th at 11:59 will be the deadline for quiz number 5, which I will post tomorrow. So I will post quiz number 5 on this chapter 6. I will post it tomorrow, Friday the 17th, and you will have 1 week to complete it, and it will be due no later than Friday the 24th. The last thing I wanted to say is once we've completed chapter 7, and that quiz, I'll be posting a quiz for chapter 7, and that will be due on Friday, May 8th. May 8th, by the way, is your deadline for all homework. No homework will be accepted after that. So you have plenty of time to complete the homework. Do not wait to the last minute. I will not give you any extensions beyond May 8th, unless, of course, it's an absolute emergency. So you must have it done by May 8th. So make sure that you're doing all the homework as you're going along, and make sure it's all completed by May the 8th, because that's a deadline for all the homework that I'm assigning. So today I'm going to assign, later on today, 6.3 homework that will be assigned. And again, it'll be due May 8th. So again, make sure you stay on top of the homework. There's plenty of time to complete it, but I will not extend homework beyond May the 8th. So once May 12th hits, you've completed test 3. That'll be it for the course. I should have all the everything that I need to give you your final grade. All right, that's it for today. So have a good day, have a good weekend, and I will see you again on next Tuesday. All right, see you later.